Welcome. We're living in a world that is just drowning in data. But how much of it do we actually get? Today, we're going to decode AP statistics and find out how it teaches us to find the real story hidden inside all those numbers, going way, way beyond just textbook formulas.
I mean, just think about your daily scroll, right? You're getting hit with headlines, charts, bold claims, all of it. How do you possibly know what to believe? Well, answering that question, that's the core mission of AP statistics. It's all about learning how to separate that meaningful signal from all the distracting noise out there.
So here's our game plan. First, we'll look at the why behind the whole AP program. Then, we'll dive right into the heart of the course. We'll see how statisticians explore patterns, how they gather solid evidence, how they master the rules of chance, and then how they put it all together to draw conclusions that can actually change how we see the world. All right. First up, it is so important to understand that AP isn't just about cramming facts for a test. Nope, it's a whole philosophy of learning, and it's grounded in some really powerful principles. You can think of these principles as the DNA of every single AP course. It's all about being open to new ideas, respecting different perspectives, and, above all, putting evidence under a microscope. The goal isn't to tell you what to think, but to give you the tools for how to think critically, no matter what the subject is.
I just love this quote. It really gets to the heart of it, doesn't it? This course, and really the whole AP program, is designed to make you comfortable looking at raw evidence and drawing your own conclusions. And that right there is the foundation for everything we're about to talk about.
Okay, so with that evidence-first foundation set, let's get into the specifics. The journey really starts with a simple question. When you're faced with a giant mountain of data, how do you even begin to find the story that's hiding inside?
The course basically builds like a story. You start by learning how to visualize and describe data, first with just one variable, then exploring the relationships between two. Next, and this is crucial, you learn how to collect data you can actually trust. That foundation then lets you understand the rules of probability, which ultimately unlocks the most powerful tool in all of statistics: inference. You know, the very first thing a statistician asks is, what kind of data am I looking at? And it really boils down to a simple choice. Are you sorting things into categories, like someone's dominant hand, left or right? That's categorical. Or are you measuring something with a number, like a child's height? That's quantitative. And trust me, getting this right from the start is everything, because it decides which statistical tools you can even use.
So let's say you have two things you can measure, like, hours you spend studying and your final test score. Do they move together? That's where correlation comes in. Think of it as a single score, called R, that goes from -1 to +1, and it tells you the whole story of their relationship. A positive R means they rise together. A negative R means one goes up as the other goes down. And a score near 0, that just means there's no real line-like pattern there at all.
And this brings us to what is, without a doubt, the most important rule in statistics. Say it with me. Correlation does not imply causation. Just because two things are related doesn't mean one causes the other. For example, ice cream sales and shark attacks are correlated. Yep, they both go up in the summer, but one doesn't cause the other. There's a third variable, hot weather, that's driving them both. Never forget that one. This leads us perfectly into our next section, because if we want to make valid conclusions, especially about cause and effect, it all comes down to how we gather our evidence. The design of a study is, quite literally, everything. This slide shows the two fundamental ways you can gather data. Are you just watching the world as it is, kind of like an observer with binoculars? Well, that's an observational study. Or are you actively changing something to see what happens, like a scientist in a lab? That's an experiment. And here's the bottom line. If you want to prove cause and effect, you absolutely have to run an experiment. So how can you possibly know what an entire country thinks by only asking, say, 1,000 people? The secret sauce is random sampling. If you let pure chance do the picking, you create this miniature, unbiased version of the whole population. It's that randomness that gives you the statistical confidence to generalize your findings from a tiny group to a massive one. It's pretty amazing. Now, we've used the word chance a few times. That's because randomness isn't some nuisance in statistics. It's the engine that makes the whole thing work. Understanding the laws of probability is what allows us to measure uncertainty and make really smart predictions. This shape, it is everywhere in nature. It's the normal distribution, what most of us call the bell curve. And it follows this surprisingly simple rule.
If you measure how spread out the data is, what statisticians call a standard deviation, you find that for a bell curve, about 68% of everything falls within one step of the average, 95% within 2 steps, and nearly all of it, 99.7%, within 3 steps. It's just this beautiful example of predictable randomness.
Okay, get ready for this because it's amazing. This is the central limit theorem, and it's honestly one of the most powerful ideas in all of science. Here's the magic. It doesn't matter how weirdly shaped the original population is, if you start taking samples and calculating the average of each sample, the distribution of those averages will magically start to form a perfect predictable bell curve. And the bigger your samples get, the more perfect that curve becomes.
And this is why it all matters. This theorem is the bridge that lets us take a small, manageable sample and use the predictable math of that normal curve to make confident, intelligent conclusions about a massive, unknowable population. It is the key that unlocks everything. So let's move into our final section and see how all of these pieces, the data types, the study designs, the probability, how they all come together. This is where you get your data superpowers, the ability to use evidence to make decisions and actually justify your conclusions.
This right here is the ultimate goal. All the work of collecting data, exploring patterns, understanding probability, it all leads to this, statistical inference. This is the formal process for using your sample to test a claim or to estimate a value for an entire population. It's how we go from just raw data to actual knowledge.
And this superpower isn't just some abstract idea. It's highly valued. Mastering these skills and proving it with a strong AP exam score is recognized by universities as proof that you're ready for high-level thinking. It's a tangible reward that can translate directly into college credit, which can save you both time and money.
Ultimately, that's what this course is all about. It's a toolkit for taking the messy, chaotic world of raw data and finding the structure, the patterns, and the knowledge hidden inside. It really helps you see what truly matters.
So we end right where we began, with a question. Learning statistics gives you a powerful new lens to view the world. It equips you not just with answers, but with a better way of asking questions. So, what will you investigate? What patterns will you find? What truths will you uncover?